I am going to teach you in this tutorial how to write and name the formulas for acids. So in brief, and there'll be more videos that are more in depth about acids, but just so you know what an acid is, just in case you haven't had that yet, an acid is a substance that produces hydronium ions in solution. You can think about it this way. If you had hydrochloric acid, which is HCl, and you dropped it in water, so let's say we have a beaker of water here, that acid is going to dissociate. Another word you may hear is ionize. And what that means is it's going to break up. Think about it uncrisscrossing. The two original ions that made that HCl, the H positive and the Cl negative, are going to come apart. And they're going to come apart in a 1-to-1 ratio because there's one hydrogen to every one chlorine atom. Most of you at this point have not made it that far in the course to really understand that, but that just gives you a little insight about what's going on. The important thing is that you can see hydronium ions in this solution, and hydronium is just one of our polyatomic ions. My students have these memorized. Hopefully you've seen that before and you know what it is. Now, likewise, our hydronium ion can be bonded to a polyatomic ion. In that case, this is sulfuric acid. If you dump it in water, it's going to dissociate, and you're going to get one hydrogen per every, actually that's wrong, you're going to get 2 hydrogens. I just caught my mistake here. It's like a rookie mistake. I can't believe I did that. You're going to get 2 hydrogens to every 1 sulfate. So that's a great thing about saying things out loud while you're studying and learning chemistry or just doing anything. Helps you catch your mistakes. I could start the video over, but I think it's important for you to see we all mess up. So that's 2 hydrogens per every 1 sulfate. Now, another way that we can describe acids, we can describe them as a hydronium ion, which is bonded to a nonmetal or a polyatomic ion. There are actually lots of definitions out there for acids, and they're all correct. They just explain different things about those acids, maybe how they behave, how they look, whatever. But these are 2 of the most common ways that you will hear acids described. So for you guys, the easiest thing to do is when you're looking at a chemical formula is that if you see an H in the front, it's probably going to be an acid. I always tell my students that is your big clue. So look for that H in the front. There are some exceptions, but we're not going to get into those today. So for example, HCl, HBr, H2SO4, and HClO3. What all of these acids have in common is that they have an H in the front, which makes them very easy to pick out. Also, it's okay to have more than 1 hydrogen in the front. That's called a diprotic acid, and you'll learn more about those when you study acids and bases. Also cool, these are crisscrossed together just like our ionic compounds, and since you already know how to do that, that's not really anything new. And what I mean by that is if you're just joining my videos, when we talk about crisscross, we write the cation and its charge, the anion and its charge. We grab just the numbers, we move this number here, the charges just kind of poof, disappear. That's Mother Nature taking care of balancing out those charges. And because this is a 1-to-1 ratio, it's HBr. Likewise, with this one, if maybe, let's say you're crisscrossing the hydronium ion with sulfate, the hydronium ion has a +1 charge, sulfate has a -2 charge. The 2 came here and the 1 came here, and that's how we get H2SO4. So anytime you are looking at the name of an acid, you now know that it's just hydronium crisscrossed with either the nonmetal or the polyatomic ion to actually write the formula. So I'm going to teach you first how to look at an acid formula and how to name it. And there are 2 types of acids that we are going to look at today. And the first type of acid is called a binary acid. A binary acid is simply the hydronium ion crisscrossed with a non-metal. So again, they are crisscrossed together. And you know that your nonmetals are located on the upper right-hand side of the periodic table. Remember that stair-step line, your nonmetals are located right in that area. So we're going to look at these and name them. Now, the rule for naming these is just super easy. For all of these, you know they're acids because there's an H in the front. You know that all of these are bonded to one nonmetal. You have a fluorine, a chlorine, a bromine, and an iodine. That makes these binary acids. So to name a binary acid, you're going to write the word hydro, so H-Y-D-R-O, and then you're going to write the name of the element, but you're going to change the ending to ic, I-C. So this would be hydrofluoric acid. I like to tell my students, you look at it and you say hydro whatever ic acid. And the whatever is the nonmetal that you have right after the H. This next one would be hydrochloric acid. This one would be hydrobromic acid. And this one would be hydroiodic acid. So the only thing that you really need to remember on a binary acid, and I'm going to put it right here so you can see all four of these that we just did, is basically you are writing hydro in the front, you are changing the ending to ic, and adding the word acid. That's it. Now I do want to show you over here at the side where these guys came from, why they're written this way, just to drive that point home one more time. This came from H positive 1 and F minus 1. We know that like charges cancel. That's how we got HF. This came from H with a plus 1 and Cl with a minus 1. The ones cancel. That's why we have HCl. This came from H with a plus 1. When you see bromic, you know that came from bromine, which has a minus 1. The ones cancel. HBr. And the last one was hydrogen with a plus 1. Iodine, which turns into iodide with a minus 1. The ones cancel. HI. So again, you write these just like you write ionic compounds. So I've got a little note for you here at the bottom that you may want to jot down. This is just the easiest way to remember it. For binary acids, which are hydrogen plus a non-metal, it is hydro whatever ic acid. And yes, it really is that easy. So that's how we handle binary acids. Now I have one more type to show you, and these are called oxyacids. Oxyacids are hydrogens that are crisscrossed, or I should say hydroniums, that are crisscrossed with a polyatomic ion, and in this case polyatomic ions that have oxygen in them, thus the name oxyacids. Now here I'm going to have to change things up on you a little bit. Those of you that have been with me on these other tutorials, you have heard me say over and over, don't change the ending of a polyatomic ion. Never change the ending of a polyatomic ion. When you're writing the name, just write what it is. Well, today I'm going to change that rule up on you. So I'm going to go ahead and direct you to this little rule at the bottom so you'll know what we're doing. If your polyatomic ion ends with ate, you are going to change that ending to ick. If your polyatomic ion ends with ite, you will change that ending to us. I ate too much and got sick. I had a fright and got nervous. Yeah, that one was a little bit of a stretch. That's the best I could come up with. So had to misspell fright there, but it works. I ate too much and got sick. I had a fright and got nervous. Also, unlike binaries, we do not put the prefix hydro in the front. No prefix, but you change the ending. So again, it's a different set of rules for oxyacids because we are simply playing a different game, if you want to think about it that way. So let's take a look at these examples. So the first one I see is HNO3, and I know right off it's an acid because it's got an H in the front. But I also noticed that this particular hydronium is bonded to a polyatomic ion, and that polyatomic ion is nitrate. And let's just make a little note of that. Now, because it's involving a polyatomic ion, number one, I know I won't use hydro in front, but I also know I'm going to have to change that ending, and 8 turns into ick. So we'll just make a little note there. So this is going to be nitric acid. Number 2. I recognize it immediately as an acid because there's an H in the front, and this time I notice it's with nitrite, which is also a polyatomic ion. So we're going to make a note of that. Now we know that ite turns into us. No hydro in front because it's an oxyacid, so this is going to be nitrous acid. All right, the next one. Again, I say, wow, that's an acid because it's got an H in the front. This one happens to have 2, doesn't matter, still an acid. And I see that it is combined with the polyatomic ion carbonate. I know that 8 turns into ick. Therefore, this is going to be carbonic acid. Notice no hydro in the front. All right, let's take a look at H2SO4. This is a pretty common one. Some of you probably already know what this is, but we're going to work through it. H in the front makes it an acid. I see sulfate, so we'll make a note of that. 8 turns into ick. And this is what we refer to as sulfuric acid. No hydro in the front. If someone says, why are you not putting a hydro in front of that? Let's say you were trying to teach this to a friend. You would simply tell them, we do not put hydro in front of an acid that contains a polyatomic ion. And let's take a look at the last one. It's an acid because there's an H in the front. BrO3 is bromate. Eight turns into ick. So this is bromic acid. And that's all you do. Now, I am going to go back real quickly and just show you how these were crisscrossed together, just to review that. Honestly, you can never review that enough. So, the nitric acid came from hydronium ion crisscrossed with nitrate. The ones canceled. That's how we got HNO3. This came from the hydronium ion crisscrossed with nitrite, NO2 -1, the ones canceled. That's how we got HNO2. And I'm just taking these names really and working backwards. Carbonic acid came from the hydronium ion and carbonate, which is CO3 -2. That too came down here. That's why that has two H's. So that's H2CO3. Likewise, sulfuric came from the hydronium ion, crisscrossed with sulfate. Again, a -2 charge, which came down here. So that's H2SO4. And then bromic acid came from that hydronium ion, crisscrossed with the bromate ion. The ones canceled, and that's how we get bromic acid. So I'm going to put this note down here for you one more time for just a second. Take a quick look at it. Maybe pause the video, make a few notes. So if I were doing my own notes on this, I might make a little, like a T-chart, and maybe compare binary and oxyacids, maybe binary on the left, oxyacids on the right, and then the rules down each side and some examples. You know, obviously you can arrange that however you want, but I think that might be a cool way to do it. So now I'm going to give you guys a chance to try some on your own. So I'm going to put these up, copy them down, pause the video, copy them, and then I am going to go over them with you. So I'll put this part up first and give you a chance to pause the video and copy them. And now I'll scoot it up for you to get just the last few. On the bottom half, we're actually going to go the other way. We're going to go from name to formula. All right, so let's take a look at number 1. I bet you guys got all of these right. So HClO4. I know it's an acid because there is an H in the front. I know that ClO4 is perchlorate. Because this is a polyatomic ion, I'm going to change the ending from ate to ic. So this is perchloric acid. Because it has a polyatomic ion, there is not a hydro in front. Very important to remember, because number 2 is a little tricky, and that's why I put these side by side, because I wanted you to see the difference. Number 2 is also an acid because it has an H in the front, and it also has a polyatomic ion. But this is the hypochlorite polyatomic ion. Not hydro, it's hypo, H-Y-P-O. Hypo is actually a part of that polyatomic ion's name. So this is hypochlorite. Ite turns into us. So this is hypochlorous acid. So I do want you again to note that's not hydro. We only use hydro in front of a binary acid. Hypochlorite turned into hypochlorous. So that's a subtle little difference, but that's why you need to know those polyatomic ions really well so you can recognize those things. All right, number 3 is actually a binary acid because it is hydronium crisscrossed with a nonmetal. And this nonmetal is going to be the sulfide ion. That's going to turn into ic. So this is actually hydrosulfuric acid. Now, the reason it had hydro in front is because this is binary. And we can use hydro in front, we do use hydro in front of a binary, a metal with a nonmetal. Another little tricky to put together. This is an acid with a polyatomic ion, and this polyatomic ion is sulfate. 8 turns into ic. So sulfate is going to turn into sulfuric, but this time there is no hydro in the front because we don't put hydro in front of an acid with a polyatomic ion. So this is just sulfuric acid. That is a picky yet extremely important little detail because these are not the same thing. So you would have to be really careful when you're using your naming rules, knowing the difference between a binary acid and an oxyacid when you use hydro in front and when you don't. So I like these two to be done together, and I like these two to be done together so that you can see those really what appear on the surface to be very minor differences, but they're really a big deal. Okay, let's take a look at number 5. If BrO2 negative 1 is bromite, what would HBrO2 be? Well, this is hydronium crisscrossed with a polyatomic ion. My students don't have this one memorized, but if I tell them this is bromite, they know, following the rules, that ite is going to turn into us, so they would know that this is going to be bromous acid. Now let's look at number 6. This is another polyatomic ion that I have not required my students to memorize, but I would want them to know how to handle it. So if I were to tell you BrO negative 1 is called hypobromite, what would be HBrO? And what's happened is that hydronium has crisscrossed with this and the ones canceled. So this is the resulting formula for that acid. So I know that if it's a polyatomic ion, I'm not using hydro in the front, but I know that ite is going to turn into us. So this would be hypobromous acid. Remembering that hypo is actually part of the name of this polyatomic ion. So we're not adding hydro. Lots of attention to details there. Okay, let's look at 7, 8, and 9. So this time I am giving you the name and I'm looking for the formula. So phosphoric acid, that came from phosphate because 8 turned into ic. So I'm kind of thinking backwards here. I know that hydronium has a +1 charge. I know that phosphate is PO4 3 negative or -3 because that's a polyatomic ion and we have memorized that. The 3 comes here, the 1 comes here, so that is H3PO4. So you have to recognize that that ic came from an 8 and then you have to know that phosphate's a polyatomic ion. You can pretty much guess that came from a polyatomic ion because this name did not have hydro in front. So there's you a little clue. Now number 8 is hydroiodic, and as soon as I see hydro, I know that this was a binary acid. It was just a metal and a nonmetal, and it looks like it was hydrogen with iodine or iodide when it's an ion. So H +1, I -1, the ones cancel, HI. That makes sense because it's a binary acid, hydro, whatever, ic, hydroiodic. And the last one, carbonic acid. I noticed that hydro is not in front. That's a clue for me that this is a polyatomic ion, and I know that the carbonic came from carbonate, and carbonate CO3 minus 2. So the hydronium ion crisscrossed with CO3 minus 2, crisscross, that's H2CO3. And again, I could look at this and I could say that's an acid with a polyatomic ion, that's carbonate. Carbonate turns into carbonic acid. So that is your lesson on naming and writing formulas for acids. The best advice I can give you is just keep the two sets of rules separate. Binary is hydro, whatever, ic. And oxyacids, you change the ending of the polyatomic ion, ate to ic and ite to us. And I'll put those up, those two sets of rules up for you real quick together, just so you can look at them. Let's try to get them all here in one screen. So for binary, there we go. For binary, you're going to say hydro, whatever, ic, acid. For oxyacids, the endings ate to ic, ite to us. Don't use hydro in front. And that sums up how to write and name formulas for acids.